So in continuation, let's see RC series circuit with alternating voltage. Right? We have already seen AC through resistance, inductance, capacitance, and last class also we had discussed about AC through RL circuit, resistance and inductor. Right? Today let's see how AC through capacitance and resistance varies. Right? This is one capacitance, correct? And this is one resistance. Connected to AC. Okay. Let this is E, that is EM sin omega t. This is capacitance C, resistance R. Drop across capacitance is VC. And drop across capacitance is VR. Correct? Okay. And this E is nothing but E naught sin omega t. Right? Yes or no?
Yes, sir.
And let I be the RMS current that is flowing. Correct? Let I be the RMS current that is flowing through the circuit. And potential difference across the capacitor, right? Potential difference across the capacitor is going to be how much? I into XC, right?
Yes.
And in capacitor, what happens? Current leads the EMF by an angle pi by 2.
Pi by 2, yes.
In capacitor, what happens? Current leads
Lead.
EMF by an angle pi by 2 when AC flows through conductor. When AC flows through conductor. Correct?
Yes.
And what is the voltage drop across resistor? Same I into R. Correct? Okay?
Yes.
And in resistor, you know, voltage and current are in same phase, right? And here, अगर यहाँ पर हम फेजर डायग्राम बनाएं, let's take the voltage as reference, right? This is voltage across resistor और ये resistance का, right? और resistor में voltage और current same phase में रहता है, right? है ना?
Yes.
तो अभी इस डायरेक्शन में क्या लगेगा? वोल्टेज
VC.
क्या करता है? करंट लीड करता है, तो दिस इज गोइंग टू बी VC, राइट? और दैट इज योर
Yes.
इंडक्टिव कैपेसिटिव रिएक्टेंस XC, है ना? So the net EMF will be, let parallelogram law of vector addition, E, right? This is E, correct?
Yes, sir.
If this is O, this is B, this is A. So OA represents, OB represents negative y-axis, represents the current along, right? BC is the voltage represented by OB, and VR is the voltage represented by x-axis, so that is current also, correct? And the resultant potential difference of VC and VR is represented by OC. Let this point is C, OC, right? This is resultant, correct? And
Yes.
अगर हम OC निकालेंगे, if we'll be finding OC, then OC is nothing but OS square plus OB square root under, correct?
Yeah.
That is E is equal to VR square plus VC square root under. So we can write E as I square R square plus I square X square root under. There is I taking common. E is equal to I coming out. There is R square plus X square, right? That I is equal to E by R square plus X square root under That is known as Z, right? Impedance in RC circuit, CR. Correct? This ZCR is nothing but impedance in RC circuit, right? That is the effective opposition offered by the capacitance and resistance circuit to AC, which is known as impedance. This is known as impedance of RC circuit, right? This is impedance. That is equal to R square plus X square root under. That is also equal to R square plus 1 by omega C whole square. Yes or no? X is equal to 1 by 2 pi FC, that is 1 by omega C2. Correct?
Yes, sir.
अगर हम resultant EMF की बात करें, that is phi. Tan phi की अगर बात करें तो that is P by B. This is, you know, VC and this is VR, right? So if we'll be saying about phi be the angle made by E with X axis, then अगर direction की बात करेंगे तो tan phi is equal to how much? AC by OA. That is VC by VR. VC is nothing but IXC and VR is nothing but IR. So II cancel. So that is tan phi is equal to XC by R. That is equal to I by XC is 1 by omega C and नीचे था R. तो कितना हो गया? C omega R. Correct? Are you getting?
Yeah.
XC is 1 by. This is 1 by omega C and नीचे R था. तो 1 by C omega R हो गया. Correct?
Yeah.
And in the overall circuit, EMF lags behind the current, right? है कि नहीं? By an angle phi. है ना?
Yes, sir.
And that I is equal to E net EMF by impedance through CR circuit. That is E naught sine omega. It's not exactly omega, but there is something phi, right? By ZCR. So we can write I is equal to what? I naught sine omega t plus phi. Correct? है कि नहीं?
Yes, sir.
And that you wrote here, ZCR is equal to R square plus 1 by omega C square, and omega is 2 pi F, right? So we can write 1 by 4 pi square F square and C square. Correct? है कि नहीं?
You substituted the value of omega, right?
Yes, yes, yes. And it is square. So 2 pi F C square, right?
Okay.
R square plus X is omega C का square, right? C square omega square ना?
Yes, sir.
This is XC. XC is equal to 1 by omega C. So XC square is equal to 1 by omega squared C square, right?
Yes.
Yes or no?
Yes.
So overall, you can see one thing: the impedance in CR circuit is inversely proportional to 1 by frequency. Can we conclude that because it is root under? Yes or no? This is frequency. So overall, if I'll see then impedance and frequency कैसे related है? Inversely related है.
Yes, sir.
Correct?
हाँ.
And for low frequency, अगर frequency बहुत कम होगा, पूरा DC हो गया circuit में, right? So R is going to be how much? Z is going to be how much? Infinity, correct?
Yes, so capacitor allows the free flow.
So that is tan phi
Yes,
is
sir.
equal to, you know, omega C into R. Omega is 2 pi F, so 2 pi F into C into R, right?
Yes.
Okay.
Yes.
So as F increases, phase angle decreases, right?
Yes.
क्योंकि नीचे रह रहा है, phase angle high decreases. Understood?
Yes.
Let's see next AC through LC series circuit, right? This is inductor, this is capacitor, and and we're giving the AC. That is E, this is L, and this is C. Voltage drop across inductor, let VL, and voltage drop across inductor capacitor, let VC. Correct? And we can also say the same way. What is VL? Voltage drop across inductor, I into XL, that is inductive reactance. Correct?
Yes, sir.
And in the inductor, what happens? I lags. I
I
lags.
lags by pi by 2.
Yes, I lags VL by an angle pi by 2. Correct? And potential difference across capacitor, that is VC is equal to IX. Correct? Beginning. But यहाँ पर
Yes.
क्या होता है? I VC by an angle same pi by 2. Correct? If we'll represent in phasor diagram, है ना? चलो phasor diagram में represent करते हैं. If this is x-axis and this is represented by I, total current, right? Yes or no? So what happens in inductor? Current lags, तो मतलब voltage ऊपर की तरफ जाएगा. This is VL, correct?
Yes, sir.
And this is VC. Getting or not?
Getting, sir.
This is VL and this is VC, correct? So the
Correct.
net potential difference will be how much? The resultant potential difference. The resultant potential difference will be how much? That is net voltage is equal to VL minus VC. क्योंकि एक ऊपर की तरफ है एक नीचे की तरफ है, right? Net will be subtracted. IXL minus IXC, right? That is I into XL minus XC. Correct?
Yes, sir.
And XL is how much? Omega L. XC is how much? 1 by omega C. है ना? So completely you can write, if we will go for magnitude, then that is impedance through LC. This ZLC is what? Impedance of LC circuit, right? Correct or not?
Correct, sir.
See one thing. If omega L is going to be greater than, that means I want to say XL is greater than XC. This is one subcase you read. XL is greater than XC. That means omega L is greater than 1 by omega C. Correct? If XL is greater, then VL will be also greater. Because XL is equal to, because V is equal to IXL, right? If XL is greater than XC, then we can conclude VL is greater than VC. Correct?
Correct.
The net potential difference, you are saying V net is equal to how much? No, sir, VL minus VC. Is that clear?
Fine, sir.
And now current lags the voltage by pi by 2. क्योंकि अगर ये मेरा करंट था x एक्सिस पे, राइट? This was VL and this was VC. I wanted to find VL minus VC. So VC will be minus VC will be in this direction, na? So as a result, this is going to be VL minus VC and current will be as usual, right? Getting or not?
Getting it, sir.
So this is also I lags. This is also I lags voltage by pi by 2. है ना? Understood ये वाला part?
Yes.
अगर XL is greater than, इससे पहले क्या था? XL is greater than XC, sir. Now let's will take XC is greater than XL, right? that means 1 by omega c is greater than omega l, है ना? That means vc is greater than vl, correct? Understood?
Yes.
So v net क्या हो जाएगा इस बार? vc minus vl, correct? है ना?
Correct, sir.
So vc minus vl means vc is greater. So now the resultant is going to be vc minus vl, correct? And this is I. This is 90 degree. इस बार तो नहीं कह सकते है ना कि करंट लैग कर रहा है, क्या कहेंगे इस बार? करंट लीड्स ईएमएफ.
Current is leading. Yes.
करंट लीड्स ईएमएफ by pi by 2, करेक्ट है ना?
Yes, sir.
एंड अगर और एक केस देखेंगे, इफ ओमेगा एल इज इक्वल टू ओमेगा सी, that means xl is equal to xc. I told xl is equal to xc. That means omega l is equal to 1 by omega c, है ना? Correct? Then
Yes,
z
sir.
is going to be how much? Omega l minus 1 by omega c. So that impedance is going to be 0.
Okay. Yeah, because XL equal to XC.
Cancel out हो गया.
Yes.
So current I is equal to E by Z. Yes or no?
Yes, sir.
अगर वोल्टेज VC greater than VL हो या VL greater than VC हो, so in both the cases the current is going to lag, or means voltage और current के बीच में जो फेज डिफरेंस है वो पाई बाय 2 हो रहा है ना
Yes.
दोनों केस में.
हाँ.
और हमने एक पढ़े थे पावर फैक्टर. We learned something power factor, right? Yes or no? Cos phi.
Yes. VRM is IRM is cos phi.
Yes, that is power, but there was something cos phi, that is power factor, cos cosine of the angle between voltage and current. So in LC circuit always the phase difference is pi by 2. So cos phi is cos pi by 2 is 0. Correct? है ना?
Yes.
So power consumed in LC circuit is what? Power consumed in LC circuit is what? P is equal to VRMS into IRMS into cos phi, that is 0. So power is equal to 0. Correct? है कि नहीं? तो एक पॉइंट यहाँ पर हम कंक्लूड कर सकते हैं, in LC circuit no power is consumed, right? है ना?
हाँ.
Understood?
Yes, sir.
और एक ऐसा at a maximum point you see, ये जो केस हम देख रहे थे, अगर Z 0 हो जाएगा तो I क्या हो जाएगा? वेरी हाई, राइट?
Yes.
I becomes maximum. Yes or no?
हाँ.
And there is a particular frequency when omega L is equal to 1 by omega C, right? When current becomes E by Z, that is maximum. That is known as resonant frequency. That is known as what?
Resonant
Resonant
frequency.
frequency, right? At a particular angular frequency, at a particular angular frequency, right? Omega L is equal to 1 by omega C, correct? Yes or no?
Yes, sir. Yes, sir.
and I is equal to E by Z. Yes or no?
Yes. Yes.
So that becomes maximum. That becomes maximum, that is I naught. And in this case, we say resonant occurs, right?
Huh.
Correct. At
Right.
resonance, Z is equal to 0, right? At resonance, Z is equal to 0 and I naught is equal to E naught by Z. That is equal to infinity, correct? Yes or no?
Okay. Yes.
And resonant angular frequency and resonant angular frequency that is omega naught is equal to 1 by root over of LC, correct? And omega naught is how much? 2 pi into F naught, correct?
Yes.
So you can write resonant frequency is resonant angular frequency, right? Yes or no?
Yes.
Then resonant frequency F naught is equal to how much? 1 by 2 pi root under LC,
Okay.
correct? Yes or
Yes.
no? You know?
Huh.
And the assignments that I had given you, go through that, we'll discuss that directly, right?
Okay, fine.
Then we'll go for, let's go to SC through LCR series circuit, right?
Huh.
Let's go through LCR series circuit, correct?
Yes, sir.
Give heading AC through LCR series circuit. Correct? Correct. That means we'll be going through inductor, capacitor, and resistor, right? Connected to EMF, that is E, and this voltage is VL, this voltage is VC, and this voltage is VR, right? Similarly, in the same way, I amount of current is flowing. You can say VL is equal to how much? I into XL, correct? VC is equal to I into XC. And VR is equal to how much? I into R, correct? Yes or no?
Yes.
अगर हम इसको फेजर डायग्राम में देखेंगे, if we'll see this one is phasor diagram, correct? Let's take it as reference, right? And let us take this one as voltage through resistance or R, and that is also I, correct? V and I in same phase for resistor. And in this part we are going to VL. In this part we are going to VC, correct? Yes or no? And most probably we take what? Net is here, let VL minus VC. We have accepted here VL is greater than VC, right?
Yes.
So if this is VL is greater than VC and this is IR, so this is going to be the net EMF E, correct? And the angle made by the x-axis is phi.
Yeah.
Correct. We have accepted here VL is greater than VC, correct? Yes or no? So you can see the net EMF, we can give as net EMF is equal to how much? V at square plus VL minus VC ka whole square, correct?
Hmm.
And taking I out, you can write here R square plus XL minus XC का whole square, है ना?
Okay.
And this is equal to E is equal to I into Z. This Z is nothing but impedance, that is R square plus XL minus XC का whole square का root over.
Yes, sir.
Understood?
Yes.
Hmm?
Yes.
Understood or not?
Understood.
Then you can take I is equal to how much? So E by Z, that is R square plus XL minus XC का whole square का root under, right? Okay,
हाँ.
नहीं?
हाँ.
And you can put, if we'll be find the phase angle, that is tan phi is equal to R by Z, right?
Okay.
So that is tan phi is equal to VL minus VC. See this one, tan phi, right? This is VL minus VC, na? Correct?
Yes, VL minus VC by VR.
Yeah. So that you can write also IXL minus IXC divided by IR. That is equals also XL minus XC divided by R. Correct? We can also write tan phi is equal to omega L minus 1 by omega C whole divided by R2, right? है कि नहीं?
Okay. Yes.
एंड कहाँ कब लैग करेगा, कब लीड करेगा, इट आल्सो डिपेंड्स ऑन कि VL ज्यादा बड़ा है या V नॉट, दैट इज E नॉट बाई Z इंटू साइन एग्जैक्टली तो ओमेगा टी नहीं होगा, कुछ प्लस और माइनस हो सकता है। ये किसके ऊपर डिपेंड करता है कि VL ज्यादा है या VC ज्यादा है, राइट?
Okay.
अंडरस्टूड? तो जब XL इज इक्वल टू XC हो जाएगा, at that time the impedance is going to be R, right? So that is purely resistive circuit, right? Pure resistance circuit. Understood?
Yes.
है ना?
हाँ.
So any circuit will be getting out of that, right? It's a combination of any type, RL, RC, RLC, right? Should you just go through the assignment that I gave, right?
Okay.
We'll discuss the numericals on that, right?
Fine.
And tomorrow morning we'll see the next, right?